Okay, so now that we know a bunch of our definitions, let's go ahead and try an example. So this example in the text is about combining vectors, and we're asked to sketch them. This is example 2.2. All right, so given the vectors v and w shown in this sketch, let's sketch 3w, v plus w, and 2v minus w. All right, so let's see. Well, here's my vector w, right? If I'm going to have an initial point, see if I can match this up. So this is about 2 finger lengths. Let me see if I can get it correct. Come on, you could draw a straight line. All right, so let's say this is our w, right? So 3w is going to have that same direction, but the length is going to be tripled. So we have our w, and then we have our 2w, and then we have our 3w, right? That does not look right at all. I can make it a little bit better than that, I think. There we go. Fantastic. And actually, this is really interesting because the way that I did this was putting w on top of itself and then on top of itself. It looks like 3w is actually w plus w plus w. Interesting. Okay, so repeated addition does give us scalar multiplication. Cool. All right. V plus w. Now, v looks a little bit different, right? V is in the opposite. It looks like it's like 90 degrees from w, and it looks like it's like twice as long. So I don't know what it is with my ability to draw a straight line. Let's see. We'll call this V, right? This is terrible, absolutely terrible. Let me try again. And I'm no con, I'll tell you. All right, so here's my vector V. So V plus W. So to go ahead and take that vector V and draw it, is there like a possibility of straight lines, right? Let's see what I can do. Yeah. There we go, that's better. Awesome, okay. There's our vector V. All right, and now I'm going to take that vector W and make sure I've got the same length and the same direction. Cool, so this all together, we have our V, our W, and so here is V plus W. Awesome. All right, and then for part C, we're interested in 2V minus W. So this seems like it's going to be more annoying than anything else. So we need to start with 2V. All right. So I've got, no. I'm gonna start down here. All right, so using this tool here, there's about my V. I want 2V, so I'm gonna make it twice as long, right? Okay. I don't want to keep going back to it. All right, and then can I move it just a little bit? No? All right, we're gonna pretend that that's accurate then, unless it lets me. OneNote is not very good for this stuff, huh? I don't know how Khan does it, honestly. All right, there's my V. Let's just run with it. And then I've got my negative W. So negative W means I'm going to start here and go in the opposite direction of W using the same length that W has. All right, so here is my 2v. Here is my negative w. And I'll use purple this time. And again, it's just a sketch. Doesn't have to be perfect, right? So this arrow here is going to be the vector that we're actually interested in, the 2v minus w. All right, and there we have it. Let's see, let's check our answer with what they have there. Okay, so the vector 3w has the same direction as w and it's 3 times as long. Okay, so we've done that correctly. Use either addition method to find v plus w. All right, I think my initial vector v was a little bit too steep, but in general, they look all right. So I'll call that a win. Okay, and then to find 2w, first we make sure we go twice as big, then we get our negative w, and we have our final result. They've drawn in red and I've drawn in purple. That one looks a little bit better. Fantastic. So I think that's it for that example.